So you're building like all so that's why I'm bringing that the PCR and then probably I haven't done that yet. I used a regular.
Okay.
You have to be tapping on your head.
Yeah, I think you can turn it off. I just like click
Click
one.
once, so I just want to make sure it works.
It's all good.
It's so sweet. Like the easiest, like, and like.
They should get that in.
Now the sync works really well, so I just sync instead of.
Oh, really?
Yeah.
All right, everybody, we're gonna get started. Thank you very much for coming. I apologize for the delay. Wanted to make sure people were filing in. Addresses are hard in 2019. I am Mario Loria. This is Orchestructure, made possible by all of you. Thank you for taking time out of your busy schedules to come this evening. And you know, I know it's a pain in the ass during the week and lots of stuff's going on. I have a lot of great stuff to talk about tonight. I'm going to get a little bit advanced. I'm guessing most of you know what Kubernetes is. Most of you know containers. Most of you know CI/CD. It's going to be a really fun night. George is going crazy back there, and if not all of the pizza is gone, he's going to be really mad. So eat as much as you can. There is no limit. I'm seeing plates with like 8 pieces on it, of course. So I am not going to, I'm doing the presentation tonight. I'm also doing the intro because no one else has extrovert skills except for me apparently, in the organizer committee. But I wanted to give Miranda a shout out, and she's going to just talk briefly about Duo and Duo's, this is Duo's space, and this is like the low-key Duo space. They are being awesome and letting us use this for the next 3 meetups. So this is Miranda, give her a hand. An hour early and dealt with all of my raging and all of that. Go ahead.
It'd be hard. Like Mario said, I'm Miranda. I'm a site reliability engineer here at CircleCI. If you're not familiar with Duo, many of you are, but we are a user-centric zero-trust platform. We do multi-factor authentication, single sign-on, and trusted endpoint verification, and it's a lot of fun. And we are hiring other SREs, so if you're interested in that, come find me. Or if you're interested in griping about converting Voda 2 to Voda 3 for Cloud Watch, also come find me. Logistics, there are 2 bathrooms in the hallway, but don't go out the door because it'll lock behind you. If those are both occupied, there is a bathroom around the corner. There's still plenty of pizza. You're welcome to help yourself to the Oberon that's picked up if you imbibe.
What? Really?
Otherwise,
Yeah, what? It would have been gone before we started.
otherwise there is soda and stuff. So if we run out, just let me know. I put the Wi-Fi up there. It's not heated or anything. That's for fun. I think that covers everything.
Awesome.
So
Thank you so much.
I'll turn it back over.
Thank you. Awesome. Okay. So a couple things. So some general details about what's going on with us in the future. The workshop is coming up in a couple weeks. That's Saturday, 10 a.m. Kind of mingle, hang out for an hour, meet other people, and then we really start at 11. We have 4 sessions, dual track, and so kind of like a beginner and advanced tracks. These are the 4 sessions right here, and it is going to be a really fun time. We're doing it at Ithaca again. So if you have any questions, feel free to ask us, ask us Slack, etc. And then general resources, including Detroit Meets, which is a new group of meetups that is being coordinated by actually one of my co-workers, Steve Marsh. And that's happening in Detroit, bringing together a lot of the cool technology, both development, DevOps, Kubernetes, things like that. DevOps Days Detroit, I'm still working on that, and we are looking to get awesome speakers. So please, if you have any ideas, do not be shy. You have the confidence. You can do this. Please feel free to submit a CFP. Ask me if you have any questions. And then Enter My World is an awesome domain I bought a while ago, and it points to my personal profile page. So without further ado, let's get going. So my notes are really funny. They say there will be some profanity in the form of words coming out of my face and memes on slides. and I'm Italian, so it will be loud. So the talk is called Differently Wrong, coined by a coworker I had previously about the way we approach a lot of our problems. There's really no right. This is version 0.0.0.1 of CD at StockX. This is not perfect. We didn't really dwell on a ton of things. We tried to get something out the door that worked, that moved us forward, and does a pretty good job with our Kubernetes clusters, keeps us moving and hit the goals that we're trying to hit. So let's get going. So I am Mario. You know me doing this meetup nowadays, Kubernetes office hours, a few other tidbits about me. I really love community. I love the interacting with people and getting to know what's going on and everything DevOps. My core background is really sysadmin focused, kind of networking engineering. And when Kubernetes or Docker hit the scene in 2012, 2013, containers to me were instantly the way to solve problems of how do we handle workloads at scale, right? So yeah, I use my hands a lot too. That's part of the Italian thing. So if you have questions throughout the talk, please feel free to raise your hand. I may or may not pick on you. I just want to kind of keep moving at a decent pace. So, but if something comes up, please feel free to ask. So what is StockX? So StockX is a secondary marketplace for consumer goods, really high class kind of goods, things that are limited edition, but can kind of be in the higher price ranges. Things that you can buy on eBay, but you don't know what you're getting, and the price is probably way more inflated than it should be, or deflated. And so StockX has a few cool features, including fast shipping. We verify everything that comes through us, right? So nothing is, you're not getting a product that you don't know what it is. You know it's new. Like we actually sniff the shoes, right? To make sure that we got that new shoe smell, which is a thing. So I joined last year in July to fix all the things. We fixed 0.01% of those. We're hiring, we have a ton of fun. This is my team who is actually here today. So everything I say is going to be partially right. They have the right answers, the 100% right answer. So they're sitting there in row 3. This is a picture. New Relic sends you hats if you use New Relic. I think this is New Relic, right? They send you hats. Yeah, and it's really fun. So and this is actually in one of our ops centers, someone analyzing the shoes. We actually buy the reals and the fakes, so we know what we're looking for. So StockX it's interesting. It's a little bit interesting to wrap your head around the first time, but it's really a cool concept, and we have a lot of fun. It's not as fun as his face is saying right there. Most of the time it is, but not always. So, all right, so let's look at the problem that we had. Many problems that we've had. We actually would have developers come up to us and say this. And so being a DevOps engineer, we were 25 when I joined the company. This is July of last year. We are now 120-ish total engineers, and we've been consistently about 3 DevOps people, 4-ish DevOps people now for that time. So we have people coming up to us asking us, how do I handle this deployment? How do I handle this Docker file? How do I handle this Docker Compose testing locally, getting into production? What is a pod, right? And it's like they want the 2-second answer. But you can't really give that easily. So the idea is that, wait a second, I scaled that problem. Okay, whatever. So services can be updated by one or many developers. So all developers right now have kind of admin access to deploy to our environments. And also many developers can work on many different branches and many different repos later. Manual assumptions for a lot of the things that we do. So there isn't really a guidebook for a lot of things. There isn't a run book. There isn't really a lot of process in place, and there isn't a lot of documentation. This might sound familiar to you. A lot of organizations have these problems, and Confluence doesn't solve them. That's interesting. So lack of synchronized knowledge, excessive interaction. So so Slack is crazy, and we have a support channel. We have people always talking to us and asking us questions, and that's awesome, but it also kind of stints some of the work that we're trying to do. So we're working on that we actually use a Stack Overflow internally to answer questions, which actually was relatively effective. And different paths for remediation. So if there's a problem, obviously DevOps team is usually the first responder, but a lot of the actual teams that own the services don't themselves don't have that knowledge spread out across the team to know that, hey, if this service hiccups, this is how we're gonna handle that situation. So, and I wanted to mention on the problem side, so, and I'll get into this a little bit further. So all of our, most of our infrastructure, is Kubernetes, backend and front-end services. We have some Lambdas going on. I'm going to focus mostly on our backend services running Kubernetes for the sake of this talk. And with most of that, let's see, everything is just kubectl to a developer. So developers don't really want to learn how to use it. They just want to deploy. And so what that really looks like is I pushed a code change, a image got built, and now I need to update the deployment with that image so that it rolls out on Kubernetes. It's actually a really simple task, but the problem is, what if it didn't roll out and it broke? A lot of our developers don't actually know how to reconcile to look afterwards and say, ooh, that's broken, and then we have some bad instances, right? And because we might not have health checks really ironed out the way they should be, or resource limits, things can break. So let's take a look at the goals of what we wanted. And this seems like a lot, but it really isn't. This is kind of what all of you are striving for. Just a repeatable, ephemeral, safe way to effectively deploy our code quickly, right? And so, developers can still know that pods exist. They can still know that there's Kubernetes client tool. They can still know Kubernetes if they want to. Actually, most of them want to when you talk to them, but they don't want to be the ones heavy to do that work. And that's fine. As a DevOps engineer, I see myself as someone who should do all of that work for them so that they can write code to make features and fix bugs. That should be their sole responsibility. And so deferring all of the kind of configurations that they have to deal with and the terminal hacking that they have to go through is in our job description. So handling rollbacks, we use Slack ridiculously, so linkage to maybe a Circle pipeline that failed, and then we use New Relic a lot as well. StockX being as fast as moving as it is, security is starting to get slipstreamed into things, but also we really rely on SaaS platforms, and we don't build a lot internally right now. That may change in the future. So we like to move fast. We are definitely breaking things, undeniably, but this, we're hoping to get a little bit better in terms of this is the SHA of the commit, and following that through the entire pipeline of this is actually what's running. You'll see kind of how that materializes later when I show some of the Helm examples. So this is just the tools we use. Most of you have used these before. Today's talk mostly will be centered around Helm. That is our CD tool. With Helm, we actually consulted with a company called ReactiveOps, and they did a lot of the initial work of getting us into understanding what things could look like. And so they kind of set up some sample clusters, some sample pipelines, and we didn't use those for production, but we kind of observed in kind of tuning where we wanted things to go. We still use they have an official CI image, which is a bunch of tools. We still use that for our pipelines. It's relatively quick and it has everything that we need, including Helm and other binaries. So, and then stops, we'll get into that a little bit later for secrets. We don't really like to store secrets in GitHub, but we do for almost all of them. So that solves this problem. Everything is pretty much AWS right now, including ECR, obviously EKS, using EKS CTL. And then, we use ELBs and other constructs from Amazon. So more of that a little bit later. So, all right, so I'm going to give you a relatively high-level outline of how our pipeline works related to GitHub and code pushes. I'm not going to get super dense into CI. This talk is mostly CD, so I want to keep moving on that front. So we do have this disparity between development, staging, and production. It's been a big lift to get there, but we've gotten there. And so the kind of initial go-to is Docker Compose for a particular service. When I say service, I kind of mean repo. So all of our teams have multiple services, which is multiple repos. And so they usually have a Docker file, a Docker Compose, maybe some other assets, whatnot, in that base directory. So tests, they get their Docker Compose ironed out, and then the pipeline that runs against a development cluster and might run in its own namespace. Right now, we have this concept that we're rolling out of dev 1, 2, 3 kind of thing based on your branch name. So in the CI process, CI/CD process, we run the tests, we build the image, we deploy to Kubernetes. Now, this is their branch that they've PR'd. Once we approve their PR, it is now a merge commit in to master branch. And in master branch, this is actually gated. And we may or may not do this long term. The idea is that staging should be an environment that's kind of a quality assurance environment, right? So do we give the QA team or QA members a chance to observe what's going on in that cluster? right? What is the visibility? Because a lot of people, oh, I deployed this running and staging, it works. Like, well, does it really work? Did you test those endpoints? What tests are being triggered, right? I can guarantee you a lot of the tests we have right now aren't really full integration end-to-end tests, right? So that's gated, that may change. Again, the entire pipeline runs. At this point, we've got now a proper build for the master branch commit of the code. Since we have that build, if we pass staging, we can open this gate for production, and that same built image will go to the production clusters. And so these are all, there's different clusters for each of these environments, actually different AWS environments as well. So basically we kind of say, okay, we've got this built image, we've verified it. This is the last step is staging. We verified it in staging, and we want that exact same image to be deployed to production. And so it's important to note that staging and production are both master branch constructs, right? So deploying to those happens on master branch. There isn't another step. There isn't a staging branch. There's a lot of different Git flows there. Good.
How often are you guys?
So this depends widely on the service. The answer is rapidly. If someone's got a relatively big change, they're deploying. I think Rails or monolith deploys. One time I looked in a week, it was 4 times a day on average. Other service teams might have 1 or 2 changes a day. They might have no changes for a week. So the idea is that there's always deployments happening. We just need to keep moving as fast as we can. And we break things. We break things a lot, and it really sucks. DevOps, being the small team that we are, we have more work on us that we are the first responders right now. And we're focusing on getting to a model where we can easily alert on services that are down, and teams that own that service get the ping, right? So DevOps isn't the first responder for every single incident that's happening. Obviously, if StockX.com goes down, that's, I'll look into that. But go ahead, George.
So when you say you break things a lot, how many of those are like internal things that like Kubernetes saves you, or how many of them are like user facing? Like, does the buy button not work on the website? Kind of?
I'd say a good majority are, when things really break, the breaks I'm talking about, generally pretty wide scale. In terms of the buy cell flow is broken, the main page is broken, a particular blog post that we just push notification out to 4 million people is broken. Those numbers might be slightly inflated, by the way. But either way, usually it's public facing. We do have internal breakage that kind of causes a brownout, but our customers might not see it as much. And so we see those because other people are using the platform, internal, I just deployed my service, and someone on the edge team who runs our Lambdas sees something's not right. So there's with traffic flowing through the platform, there's continuously kind of some coverage there. So I'm gonna continue from there. I think everyone kind of has an idea of what's going on with this. It's kind of 10,000 foot view. I don't want to get too much in the weeds. Cool. So we recently got into this idea of that is an awesome ringtone. Who's ever ringtone that is great. Knight Rider was my favorite show growing up. I'm a nerd. So BCS and service quality is like, this is to us where it starts, right? Implementing some adherence to a set of goals and guidelines for what we want our services to look like. And so this is, code owner is super easy to do. It's just one of those things we have to sit down, we have to decide what it's going to look like and do it. So, and I'll get to this in a minute here, the sample service and how that works. So I think the big deal here for me is kind of the quality matrix. And we actually now have an architect at StockX who is helping usher these things forward so that he can work with the teams individually and he can bounce around to help them understand what their code should look like, what deployment configuration should look like, what repo restrictions, updating your branch to latest master before merging, things like that, dependencies, all that jazz. We try to let the teams be autonomous though, generally with what their flow is for pushing code. We have some teams that are trying to do releases and tags right now. A couple of them don't use the standard technique of just branching and then PRing. They might have some other branches they want to mess around with. We may kind of standardize on that and say, no, this is how we want all of engineering to be, but right now it's relatively loose with some global guidelines coming down the pipe, depending how we want to do CI/CD and other things overall. So we define these engineering standards through a single repository, and that is our sample service. That will be what I get into here in a minute, and a lot of the code snippets you'll see from that. And so the idea with this is one repo that can't encapsulate every language, but encapsulates the most used language at StockX, which is fastly becoming known. And with that, it has all of the assets for code, for tests, for Docker, and it has deploy assets, which is what I'll be talking about here, that DevOps has inflicted, worked with other teams so they understand what's going on, made sure they work, charts, things like that. So let's get more into those. So here's the structure of the sample service. This production and staging are also in the deploy directory. So all of this is in that deploy directory on the top left there. So pretty basic. I mean, we have directories for the environments that things are going to. Those directories contain some environment variables. They contain a secret YAML, which is getting loaded in Kubernetes. That is encrypted with SOPs. More on that later. And then we have a values file for that environment. And then here it's just node service sample, our chart, the templates, and we have some hooks. And I will get to those in a little bit, and we'll probably refer back to this slide a couple times. But yeah, so the deploy directory, it sits at the root of the repo/service, and it basically is the DevOps directory, if you will. And in code owners, we actually say for deploy, if anything is changing there, then ping the DevOps team, right? So that is really, really handy. So let's get into that config.env file, which is in our environments. And you'll see there's no development folder yet. We're working on getting that rolled out here. So these are obviously specific to each environment. This actually came from ReactiveOps, most of this. And it contains some basic things about what we want things to be named for that environment as it goes to both as the image is built for secrets handling and for the Helm deployment, right? And so you can see some of the naming down here. We've since made a few changes to this to, we want things to look differently for tags or for Helm names. For the release name for what we view when we're interacting with the service in a Kubernetes cluster, et cetera. So this is relatively basic. These are all available in the CI/CD pipeline, and they are used by the tools that are being called there. So that is relatively basic. And again, these are just basic environment variables. So this is. You have
a question?
Oh, I'm sorry. Go ahead.
For like that deploy folder, that seems like sort of a lot of boilerplate to set up. And so I'm curious, like, is it the developers that do that? Is it you as DevOps engineers that jump in and do that?
Yeah, that's a great question because yep, sorry. So some of the lights are like in my face. So if I don't see, yell at me. There is this is a great question because we're trying to find that divide right now, and I think for the foreseeable future, we put this on the developers to the service owners to get to as far as they can. Like we give them a set of instructions. We say, work as much as you can. There's going to be a few steps. So the KMS key in AWS. That's something DevOps has to set up. Put in a card with us and we will get to it and get back to you and then you can continue, right? So really they can kind of copy this and then start working. What we found and what anyone's going to find is that not every service is the same. So this chart here that has config map, deployment, ingress, service, some health checks, those are going to look different in almost every case. And so we're actually lucky, and I didn't talk about our workloads much, but we are incredibly lucky that we have mostly stateless workloads. Like we don't realize that, like we don't deal with storage in our Kubernetes clusters at all. It's the most amazing thing in the world, right? Like we can just scale something to 400 and like there's 400 copies and ingress is going to all of them in magic, right? It's the greatest thing in the world. So not having to do those storage helps a lot, but with services being as different as they are, we have, the other day we had a service that we needed to, it needed to exist as a chart construct, so it needed to exist kind of as a cron job, but it was never going to actually be something we wanted to run on a schedule. And so we had to do something in that realm, and that involved a new template, and so they rely on DevOps for this. So we give them kind of, this is the starting template, the skeleton, they copy it in, they go through the steps, and they're gonna hit some little things, and we help them along the way. One more, George.
At some point, do they get ownership of those files? Like, do you like set them up and then it's on them to self-deploy, or are you always?
No. So these files are the files used in the CD process.
Okay.
So they own those files. These files are in their service repo, right? So they own these files, right? So gotcha. Okay, cool. Yeah, okay, so quickly on environment, I think I pretty much talked about what's going on. Yeah, image repository, if we want to change the name of that, you can see we've got ECR. I scrambled these, so don't try. Just saying. Pretty basic. So SOPs is a tool from Mozilla. Reactive actually turned us onto it. It uses AWS KMS to encrypt the file, so we basically do a simple export of the ARN for the KMS. We make sure our profile is set correctly. And we use SOPs, and it opens with our default editor, usually Vim, whatever you're using. Very good idea. Do not have production as your default environment in your AWS config. It's a bad idea. All right, so we're gonna kind of get into how the chart is formulated. So the chart repo is this right here, charts node service sample. And so you see your chart.yaml, which is general information, and then the templates. And so most of what we're talking about is the templates, and then there's our default values, and that's what I'm gonna get into here. So we had this idea of, when we started, we actually had staging and production would have a values file that was, 100 lines long, let's say. And it had every possible configuration option. And staging would have that, production would have that, development would have that, right? That doesn't make a lot of sense. So what we did is we sat down and said, how can we make this easier where the things that exist in a staging or an environment-specific configuration are just the things pertinent to that configuration for that environment. And so what we did is we said, we're going to make a default values. It will include everything that the service needs to run in terms of environment config, health checks, any resource limits, et cetera. And then we will make it work both in CI/CD, but also on somebody's laptop. And you'll see a little bit more of that in the future, in a few slides. Some key things here is we instantiate objects that we want to force to be configured during the CI/CD process. So using --set passed to Helm. And that basically lets us use any specific environment variables that are available during that pipeline. And then we'll actually leave things blank in the default values that we want to push onto the environment-specific config to make a decision. So ingress enabled true or false is a good example of that. So actually, any questions on that? I'm going to talk a little bit more about what's going on there. So this is kind of a sample of our default config and then our production values. And so you can see secret sum is something that we pass in during CI. The image repository is something that we tell the staging and production, right? It might exist in a different repository. Ingress enabled, domain name changes. It might be service.staging or just service.StockX. Horizontal pod autoscaler. This is it's really nice. We don't have to worry about things. And when you go in to look at the service, when anyone goes in, they can easily see what decisions they need to make when they create an environment. So any questions on that stuff? Awesome. Now, the way we save ourselves when we aren't running in CI/CD is by setting defaults so that things run. So developers aren't really going to be running Helm. That's the goal, at least, right? We've already broken that this week. So the idea is to at least give them something, and then if they don't understand what's actually going on, they can ask us further, right? So default latest, I think we do this in a couple other places, but provides that safety when they're running Helm manually on their laptop. They've got their AWS profile set up, they've got their kubectl environment configured, and they just want to get something deployed, right? And then we actually eventually will resources for them to understand, in the values, if you're seeing an instantiated object, that actually calls for something to be set. So set it on your end. And that's pretty easy to help them with. Go ahead, Josh.
Do you allow latest to go up higher than dev? That's something dangerous.
So remember in the pipeline image, we actually have two repositories. We have a staging and a production repository. And so basically, if they're running this on their laptop, I don't think we actually do anything with latest right now. I think, I could be wrong on that. I think we just, the SHA and a couple other build IDs are what the tags are. So they're actually, yeah, we don't have a latest policy right now. So someone who was working on this before was like deploying and they were like, what's going on? And they asked and I'm like, that's why you don't have a latest. And that's not intentional. It's just we were lazy, but we might actually keep it that way because why not, right? Like you don't know what latest is. No one has a clue what latest is. Like anyone can push to that in the company. So it's just a little safer. So any other questions? I'll take one more on this. Cool. You guys are awesome. So I'm going to start getting into some of the things that went into those templates for Helm to help make our deployments a little bit safer and kind of the way we think about running our applications in our Kubernetes clusters. So a lot of this is from a presentation I saw at KubeCon 2018. I forget his name. He's from Manifold, and he talked about rock solid pods, just rock solid pods in a cluster, and really helping get to zero downtime with that. Because Kubernetes provides you everything you need out of the box to do this, but everything that you want enabled to truly be zero downtime based on your services, based on your needs, based on your platform, based on your cloud is not totally there. And it can't be, that you can't have something by default that does that. But by default, it gives you a lot to start with. So this one's a really basic one. Most of you have heard of max unavailable, and you know that your deployments have a, by default, rolling update strategy. All we're saying here is that we do not want any of our capacity to change when we do a rollout. And this is changing anything for the deployment or any of the config maps, et cetera. So this basically maintains, and this is something that we do in every environment, but we want every environment to look the same in that, we want it to work the same. Some people might not set this for dev or staging. We set this kind of for everything. So it exists in our service sample. So the default is 25% for this. I think once you dial in your services, you don't exactly need this. But when you have services that are not written in the best format, don't have the best testing, you want to make sure capacity is where it should be, excuse me. So I just implemented pod disruption budget. This is not from one of our deployments. It's a sample off the internet. I don't know why I did that. I swear I pushed the PR, it's all good. So this basically, so if max unavailable is for when you change a deployment, you update your code, you want to push a new version, pod disruption budget is everything else. And this tells Kubernetes, kubectl drain, anything that uses the eviction API to make decisions. So cluster autoscaler, making decisions about, okay, it's time to scale the cluster down, let's drain some nodes, right? This basically tells it the minimum available, or we use max unavailable, of instances for your application, so pods. So if we have 15 pods of our application running, we say, I only want to be down one throughout the entirety of whatever you're trying to do to the cluster, right? Probably a scale down of that. Hey, something is broken. Might be, we want to change our instance type in AWS, and we want to roll that, which is something we did this week. It could be changing something else, host level, OS level. So this is a separate file in Helm, in your Helm charts. So this would be disruption budget.yaml. And so for us, we have it's min available or max unavailable, just like rolling updates. So we have max unavailable 1 for ours. And then again, it just uses match labels to know what your deployments are. So any questions? Cool. All right, config map and secrets. So we use config maps and secrets everywhere, and we don't have to. We could put all of our variables in the deployment, which we have for a lot of things. But we like to kind of keep those things isolated. The problem with config maps and secrets is that when they're utilized as environment variables, they do not update inside of your pod. Now, when they're mounted as storage, they do eventually, based on kubelet settings, which kubelet's the daemon running on your hosts. So what we did here is we basically said, well, we absolutely need this. And so Helm has a solution. It's not the greatest solution, but we do a SHA of the actual files in our chart. So the config map, after Helm builds it from our values files, we do a SHA of that. And if that SHA changes, it changes an annotation inside of our deployment. So here's an example of what that looks like. So this is our code for that. And so you can see we're doing a SHA-256 sum. Secret sum is actually from our CI/CD pipeline. We're getting that. And then this is kind of the resulting what you're going to get. You're going to get your SHA values for that. If that changes, then the deployment has changed. Hence, everything needs to be rolled out again. So yeah, that's one of those that not a great solution for, but it's something that we need. We can't be making changes and not have those applied. So, and even in the model, if you are mounting a config map as, as a piece of a file or something like that, even if those changes are made in the pod, you probably have to sync up your application to take them anyway, or whatever kicks your application to reconsume file system content. So linking verification, so these commands are run in our pipeline. These are actually run in the deployment step, but pre everything else. And all we're really doing here is running a basic Helm lint command to make sure that all of the chart templates, when built with the values, look sane and make sense from a Helm perspective. And then we're actually using a Belle, which is a open source project. It's not 100%, it's still heavily being developed, but it actually verifies the resulting manifests. So if Helm is verifying the chart and its structure, Belle actually makes sure that the resulting manifests that are actually getting loaded to Kubernetes look sane. And the deployment horizontal pod autoscaler, things like that. It's not really where it needs to be. We run it without the strict flag. We had it with the strict flag, and the HPA was not successfully processed. So these two commands run. If any of these fail, the pipeline dies, right? So this is kind of our safety to make sure no one fat fingered something, etc. Any questions on that? Yeah, there is actually no native linting for any of the client tools that I could find off the bat. So Belle is like it. And it's not really an official Kubernetes project. So that's something, George, we got to work on that, get a SIG to take that over. Cool. So I just talked about a ton of stuff, right? Our home deployments are awesome. We've got the structure for how we want our services to be deployed. I got more, don't worry, I'm not done. But it took a lot to get here. It took a lot of research, it took a lot of PRs, and it took a lot of effort. And this is Christian, one of our coworkers, heavily involved with robotics. And he's one of my favorite people at StockX. It took a while to get here. It took some weekends. It took things going down. It took breakage. Right now, for some of our services, we're actually deploying to old clusters that aren't actually the live clusters that clients are seeing. So things are kind of broken there. There's a lot you can do, and there's a rabbit hole that you can go down with some of this. The idea is to think about what you want out of your pods and your services, whether it's a front-end service, a back-end service, whatever your Kubernetes clusters are set up as, however beefy your nodes are. Think about what you need for your organization and try to find the enhancements that, I'm an optimizer. I could go for 3 years and just make PRs like this to push new YAML and new config. But there's a level where we have to stop and say, this is really good. We've got a great template. Let's move forward. Like, you're not going to get to a perfect state. And so I think a lot of teams that I've heard from are like, well, that doesn't work. Well, Helm is really a heavy lift. It is. Little things shouldn't bother you. You're not going to get it perfect right off the bat. So take a breather, look at what you're trying to do, see what you're trying to achieve based on your organization. Like I said, it's magical not having to deal with storage. It's magical having mostly stateless applications. I can delete pods left and right if I want to. Platform's pretty good. We can incur nodes going down decently well. We're getting better at that. So we found things that caused our issues, and these things that I'm talking about are helping us kind of get past those. So a few more. So this is some of this is the fun stuff to me personally. So Helm has this idea of hooks, and hooks are part of your chart, but not technically. They're not managed by Helm once they're run. They can run pre-post. They have a wait, so you can run hooks. You can have 3 hooks that run in a certain order based on what you're trying to do. Really handy for database migrations, verifying a configuration for something in the cluster, putting a secret in the cluster, and then running a job that needs to do something first, and then cleaning that up or doing some other operation, then deploying your chart, right? Hooks are incredibly powerful. I very much urge you to do this. Another thing most people don't know about is containers themselves in your container pod spec actually have pre and post hooks as well for commands they can run, which is really handy. We don't use that yet. This has gotten us pretty far, but definitely very powerful. Any questions at this point? Awesome. Probably all tired of hearing me talk. So getting atomic. So recently Helm 2.13, which side note, Helm 3.alpha just came out with no tiller. Definitely look into that, but 2. Still has tiller. And they added this option called Atomic. And basically it says, if the deployment breaks for any reason, just delete everything we tried to create and leave it the way it was before we touched it. There's a note from Bacon Gobbler, one of the core maintainers for Helm, awesome guy, talk to him, talking about kind of, okay, this isn't really truly atomic, but it's better than nothing. And it really ensures that our deployments are as safe as possible. We also use ---- force, which solves a couple other issues I can't remember right now off the top of my head. I think if the initial Helm deployment failed, no further subsequent one would process correctly, so they would just continually fail, and you would never, like, manual intervention would be needed. So force helps us through that. In kind of the overall scheme of things, you really don't want to use a force in your CD. If something's wrong, like, you should probably not do that. So Helm isn't perfect. 3 has a whole new architecture, and it's looking really promising. So definitely a cool tool. So Helm is a heavy lift. Helm is a lot of work. You're effectively saying, here's some Go templating language, build this for me, and build my manifest with it. But you're writing you're doing the heavy lifting. Customize, and there's a couple other utilities out there, I can't remember the name. I will link them after this talk. Definitely look into them if they maybe suit your use case. Helm is a really heavy lift for a really small team. And so we were a small team for so long, we really we kept looking around, we're like, someone needs to have this GitHub repo that's just amazing. It's like 7,000 stars, and like there's so much commits, and like it's going to be perfect, and it's going to make Helm look super old and stupid. That didn't come ever. We waited for it, and we looked around, and there's some projects, but nothing has really been as defined for a Kubernetes package manager as Helm. So it's incredibly powerful. It's not perfect. Again, your use case, what you need to do for what you guys are trying to achieve. So one of my other favorite things is pod anti-affinity. This actually isn't really new, but not a lot of people know how it works. So I have an example on the next slide, but we basically use anti-affinity to do 2 things. One of them is our clusters are spanned across 3 availability zones in AWS right now, US East 1A, B, and C. With that, we want to ensure pods are spread across those availability zones as much as possible. And so one of our anti-affinity rules says that, and the other one says, once we get past that, where, okay, we've now got an instance running across every zone, now find nodes that don't have our service and make sure it exists there. So we get as much balance as possible, right? And so this is something you're gonna wanna deal with depending on the cloud you're on, bare metal, what you're trying to do. You really should look into doing this. I wish there was more docs around it. We do a preferred method over a require hard method. So if we did require, we actually wouldn't be able to deploy past 3 pods. Because when we get to the 4th one, we can't explicitly put it in a zone that doesn't already have an instance, right? So that's not great. We actually run, to give you an idea of how beautiful we love to scale, I would say in production, most of our instances are 10 plus of things, depending on what it is. So we run lots of instances. So getting a nice even balance is really important for us. And we do prefer it as well because at the end of the day, the scheduler, the Kubernetes scheduler, knows the most about the environment, and we can't really tell it beyond the basic things. Hey, go here. Sometimes we might have to have 3 pods on a single machine just because of resource contention or something else going on in the cluster. So strive to get a balance. Jelmer, Sneck, I'll get more details. That's the talk I was referring to before. So this really truly aids in highly available deployments because if 2 zones go down, right? If 1 zone goes down and all of your pods are in that zone, it's a problem. If 2 zones go down, you still have not maybe 1/3, but a few pods that can still service requests. So this gets into true high availability and rock solid deployments. And here's an example of what that looks like. It's a little bit heavy in the stanza realm. The key things here are we have our label, and this is actually this values this .app is just node service sample, and we say for all of those applications with that label, use a decision label. And if you've ever looked at the labels that are on your nodes, they have both the failure domain and the Kubernetes hostname. And this defines the zone. So in AWS, this is just natively US East 1A. And then, the hostname is whatever the host name is for the host, usually the internal private IP, I believe. So any questions? Cool. All right. Now I'm done talking about charts, I promise. So everything's in our chart. Our deployments are super beefy and super powerful, and we are really happy with them. So what's actually happening when we execute that? So this is the the function from the binary that reactive provides us. And this is how Helm is being executed. Where we actually call Helm in our CD process is right over here. It's this fourth line down here. There's a bunch of variables configuration that we pass in as a variable. And then we call this Helm deploy function with the configuration .m file. And so here's kind of where I mentioned that we have force in there. We have atomic in there. And we actually have a description. And the description contains the SHA-1 of our code, of that commit and master, right? And you'll see here in an image how that works when you're troubleshooting, et cetera. Go ahead, Jeff.
If you're forcing and atomic, are those sort of antagonistic to each other?
It's not what you think it is. And then you can see here we have cute things like Slack notifications. So we have a Circle deployments channel on a failure. And then the rest of this is, you can see set image tag, right? Relatively basic. Helm provides an idempotent way to kind of upgrade and install if it's not already existent, which is really nice. So just kind of one command and you're good to go. The namespace is defined for us, and namespace would be defined in that configuration, the config.m file. So we get our logs. So this is what we basically see from CircleCI. I moved this from there to my editor to look a little bit nicer. But this is what is being run. And you can see Helm node service sample, the chart, the values to use, the production values, set our image tag to the SHA, a few other tilde namespace, keep system, some basic stuff that you generally want to be explicit with. We have a wait, so our CD does not just continue until we know that we have been fully deployed. We have a timeout, which nothing should take 300 seconds. Our description, a few other things, some passwords, things like that. So, and this is what Helm.
It's not used for anything but this.
Yeah, exactly.
Let's have any data.
No, absolutely. Yeah, I mess with those, I promise. There's some 1, 2, 3, 4s if you look really close. And so this is anyone who's used for this is what Helm really shows you is, okay, here's what I did, here's the status, here's what's going. And then this is, I'll get to that in a minute. This is a Helm history, okay? And Helm history is the command where you basically say what's going on or what are the revisions, what has been done with this this deployment. And so you can see here, down here, here's that description. This is where that goes. So when we're troubleshooting, this is immensely helpful to see, oh, this revision was this SHA. Now we can go right back to that commit and see what was going on. So you can see here, we actually didn't have that implemented and we were still testing some things, et cetera. So tells you the exact date. Just really, really nice. Any questions? That is our architect. And this is an image that someone made. I don't even know who made this. Yeah, he's helped a lot with getting structure in place, like I mentioned, with the node service sample and other things that he's rolling out to help service teams. So, so it's time to talk about failures and things that we've done that we're not happy about, things that we've run into. I'm going to try to help make your life a little bit easier, but I think DNS is ultimately going to get you at some point in time. It happens to everyone. So you might have seen me, Jared, a few other people talking in our Slack channel actually about some massive DNS issues that we've seen with our clusters. And this was before I've done a lot of fixes. This is one of the fixes I just did recently. And this actually is DNS config that is applied to all containers in your deployment. And it basically says, NDOT's one, I'll get to that in a minute. Enhanced or extra DNS options, that's DNSSEC, and then it actually enables geolocation data to be in DNS queries. That helps Cloudflare actually route better. And then you've got single request reopen, which helps if the quad A record didn't work, but we haven't returned our A record, just send another request or disregard, don't sit waiting for it. NDOT, so really, I'll try to be really quick here. DNS in Kubernetes is service discovery. It's how services find each other, right? So if you type in pricing.db, if you're in a container, you type, curl pricing db, right? What's actually happening on the back end is your DNS resolver is trying every combination of pricing db, and it's trying every combination of both the namespace that any object could be in and the type. And I should have put it up here, but it basically goes pricing db dot namespace dot object, so service SVC Kubernetes service dot cluster dot local, and it's basically trying 4 or 5 search domains, right? And that is one of the biggest wastes of DNS I've ever seen. And so NDOT's is by default is actually 5, and the idea is to kind of make every use case. So if you type in pricing DB or you have pricing DB as a DNS name, it's trying pricing DB dot default dot service dot cluster dot local. It's trying pricing DB dot pricing DB dot default. Pricing DB, it's trying all of these different combinations, so you're incurring a ton of overhead, and you actually eventually get delayed DNS responses to your services, and that's not great for all services. So NDOT's 1 basically says pricing DB will work, but if someone has a name of pricing dot namespace, that doesn't work. And obviously fully qualified domain names continue working, so the whole full pricing DB dot namespace dot service dot cluster dot local works. We never find ourselves typing in service dot namespace. We don't use service discovery that intensely. This is, again, something depending on what you're trying to do, what you're trying to achieve. So we save a ton of DNS queries doing this. I will post more details on this later on as well. I have a blog post incoming talking about all of the fun that we've had on that realm. All right, so when you're moving fast, you use SAS services. And SAS services provide everything. It's just magical. It works. It's great, right? But when you start actually using it, right? When you start actually having problems, when you start actually wanting to do anything different and step out of that box, is when things can get a little bit hairy. So we were on StackPoint Cloud, now owned by NetApp. And StackPoint is actually pretty wonderful if you want to click a button and have a Kubernetes cluster. It's great. But it doesn't give you a lot of control, and it's a black box. And so it caused us a lot of issues. We were kind of locked in. It wasn't very configurable, and their certificates only last for a year. So something to be aware of. Also, IBM Bluemix, don't use it ever. Just stay away. A couple other things. So using an easy bake cluster tool, don't do it. If you're a 2-person startup and you're like, let's move fast and break things, yay, go ahead. But when you start having a DevOps team, serious scaling events, seriously, this stuff is running your core applications and your APIs and things like that. Try not to do that. EKS ETL has come really far. GKE makes this super easy. I believe there's a Terraform module for it that works. Azure is getting there, etc. Brandon's working on it. Thanks, Brandon. Health checks and resource requests and limits. Health checks are immensely important. So you got your service done, you've got the deployment all ironed out, cool, pods run, right? If you don't tell Kubernetes how to check your service, you aren't gonna have a good experience. You're gonna have a really, really bad time. If you don't tell it how to place your service based on the requests for resources that your service might need, you're gonna have a bad time because it can't play Tetris and it can't effectively schedule your application. So, these are hard to dial in, especially if you have an app that you can scale a lot, right? Like its resource request might be, super low if there's 30 instances, but super high if there's 5 instances. So this is really hard to dial in. And this kind of blends into the horizontal pod autoscaler, which I think everyone should look into for at least their applications running in production, right? And those are incredibly hard to dial in. There's going to be a lot of testing, but at the end of the day, the Kubernetes scheduler, its foremost decision-making process is really on those resource requests. So, and then limits, we had an application that would actually continually was taking down nodes. Like it would tip over nodes because of its memory usage. It would blow, we had no resource request or limits. So Kubernetes had no idea what was going on. It would place it on a node and the application would just keep eating RAM and tip the node over. And now all the workloads on that node are now being impacted. And there's a kubelet setting the pod eviction timeout, which by default is 5 minutes, which is way too long. But Kubernetes doesn't assume the pods running on that node that just failed are actually dead until after 5 minutes. And because the node actually doesn't tip over right away, it would be kind of in a flapping state. So it was never really dying. So you might have a piece of your workload that's actually just continually, seems like it's up but isn't. So the readiness probes, so there's liveness probes and readiness probes. Does everyone pretty much know what those are? There's a kind of a distinct difference between liveliness is the application running or do I need to restart it? Readiness is, can I send traffic to it, right? And so a lot of people that I've talked to thought readiness was like, oh, it's the first check that runs and it just makes sure the thing is ready to do its stuff. Nah, that's not it, sadly. So, and then obviously it's always DNS. Be aware if you're using kubeadm, bare metal, how you're building your clusters, what your internal certificate structure is like, what your timers are for those things as well. That is incredibly important. Also, I don't know if you remember, this is Ophelia, my favorite employee at StockX, probably one of the key people on my team that keeps us all sane. We'll talk about something for 4 hours, then he'll be like, why don't we just do this? And we're like, fuck it, God damn. Okay, yes. So we right now give a lot of developers a lot of power. And when you're moving fast, they just need to do things, need to get things implemented. We are slowly moving back from this, moving back permissions. So a lot of developers have AWS credentials, and those are admin credentials. And this is so they could make things if they had to bounce to S3 for something for their service, depending on what it used, they could do that. It's a little bit scary. So we had someone log in and they needed to access a service from home, and we don't have a VPN. So they edited a security group to give themselves access. But in doing so, they removed a rule to access our main monolith API, and they deleted the 443 port, and the entire platform went down. So yeah, it happens. You have to have a level of trust, but at the end of the day, keep tabs on things. We're actually working on getting SSO implemented right now as well. That's been a many-month project, so we'll get there eventually. So let's talk briefly about what's next. I'm going to stop really quickly. Does anyone have any questions up to this point? I know I'm like going on for a really long time. I've only got a couple ending things. So any questions? Cool. Awesome. Thank you guys for coming on this journey with me. There's a ton of stuff that we want to do. This is like a small sample set of what we want to do. We're looking into service mesh. We're getting caught up in what's the best. Really, we should just start testing a bunch of them in playground clusters and go from there. We're looking at, right now we use classic ELBs that are that Amazon is observing the services that are created for our applications and making those ELBs for us. Do we use ALB? Do we use Nginx? Do we use Trafic? Do we use Heptio Contour, right? There's a lot of options out there. Again, we need to start testing those. We don't have pipelines for everything. We've only got less than 10 services that have pipelines on them that are really truly deploying to the clusters they need to be deploying to. VPC restructuring. I don't even want to talk about that one. That makes me bad. Node problem detector. I think Steve Kaufman's been working on this a lot. This detects the kernel just panicked, the storage just became unavailable, things that kubelet is not going to know about because the node is still responsive, right? So this will detect those things and then work with the API to evict those workloads and get that node out of the cluster. The descheduler, one of my favorite things, runs on a scheduled timer, and it basically looks at the current state of the cluster, and it will try to balance things out as best as possible based on the resource requests and limits that you've set, and based on the overall resources available in the cluster. So this is a tool that I'm going to try to get implemented. One of the last things I want to get going to help balance our workloads across all of the nodes in our clusters. It's a little bit of work to get going. It's beta, I call it, but it does the core of its job. Really cool stuff. More on that in the future. Cluster autoscaling is working for the major cloud providers. It's a little bit tricky with multi-zone deployments when you have your cluster spanning across 3 or more zones. a little bit tricky. So some stuff to do there. And then obviously more resource requests, limits, horizontal pod auto scaling for all of our services and applications. Right now, there's like 2 of them that happen. So I'm talking about all this cool stuff, but like we're still dipping our toes in a little bit on a lot of this. So I have 2 blog posts that came out of this, some of my research for my slides and what's going on kind of at the lower level. I want to try to bring light to some of these things because a lot of the stuff you're hearing about today is like, yeah, that makes sense. That's common sense. No one's doing this though. Like that's not the thing. There's actually not really many articles about how to do some of these things on the Kubernetes official docs. So I'm trying to bring some light to when to consider a pod in a healthy and multi-container scenarios. Pods don't just go away that easily. So you're going to want to watch yourself and how your containers are dying and health checks. And then, Kubernetes probes, the liveliness, readiness. Like I said, readiness is for actually, do I direct traffic to this pod? Liveliness is, do I restart it? Drano is a tool for draining bad nodes. It works with node problem detector. And it now works on just hosts that are dead and don't seem to be doing anything. It can get rid of them a little bit sooner. So, and that's my presentation. Thank you. Okay, so I'm going to take like 4 or 5 questions, and then I will let you all go. I will be hanging around for a while. Some of us are probably going to go drinking because stack point, and
Make sure
we'll
you
go in
mention
there.
the workshop.
What's that? Oh, we're having an event? Oh, I should talk about it, right? Is that important? So the Orchestructure workshop is Saturday, June 8th from 11 to 4 p.m. Like I mentioned earlier, there's going to be 4 sessions. Please let us know if there's anything that you want to see. We are trying to, and it's completely free, food is included. We're trying to help people learn about some of these things, whether you're starting at 0, whether you're starting at 10, whether you're starting at 40 or 60. Like there's some advanced topics. It's going to be a really fun time. One of my coworkers from StockX, Stephen Wiggins, is going to be doing a talk about developer workflow. So if you're a DevOps engineer and you want to get an idea of what developers have to go through and why they don't want to run kubectl commands, he will tell you, I guarantee it. So
Where do we register for this?
you want to just get up here now? So we have a standard meetup event page for the workshop that you can go to. Workshop.orchestructure.io is the domain for the main site if you want to check out more details. So other than that, I know Detroit Meets was meeting tonight as well. They like to meet on the last Wednesday of every month like Orchestructure does. But I urge you to take a break from our meetup once only and go down there. There's a lot of cool stuff. I believe it's usually a grand circus. So definitely check out what's going in. I know there's Ruby, Kubernetes, how to start a startup, and a few other events, and I'll show them around that afterwards. So, questions? Ed?
You mentioned that your job was relatively easy relative to all jobs in the world because you didn't have to do the storage. At least your Kubernetes clusters did not have a bunch of storage attached to them.
Other than local storage, yeah.
Other than local storage. So how do you deal with storage overall in this architecture?
Distributed storage. Generally, what I hear is most people go to GulfStream, which is Red Hat, I believe, or they go to SEP, which again distributed storage a little bit. Depends on how much lift you want. There's, I'm sure, Pure Storage, EMC, I believe have solutions. Kubernetes actually I know plugs in with that. There's now the CSI, so there was the CNI for networking. There's now CSI, which I believe as of 1.14 is pretty much out of beta and stable. George, do you know?
It is GA.
Okay, so we're getting there. So Kubernetes is handling these things better, but most of this is there. If we were in AWS, I believe if we wanted to use block storage, we'd use EBS. And then there's the other one, I forget the name of it, that's NFS based, fancy NFS. So if we really needed storage, we'd probably do that EFS, just off the bat, depending on our needs. It really depends. Our services are nimble enough and they're decently modern written in terms of like they were written in the past few years that implementing some sort of like use S3 for something, use object storage, use just the local file system for very fast, like quick local stuff that doesn't need to persist. Try to get that other stuff to a Redis cache or S3 or something. Like that's not a hard lift for us. And so it's really, I have to give it to some of our service owners who wrote decent code, but they were kind of thinking about these ideas and principles when they started. So, go ahead.
The quick follow-up to that is like, where do you actually, I mean, like, your entire business can't be stateless.
Yeah, it is.
Like, there's no storage anywhere, like.
No, never, ever, no.
There's gotta be some database.
So, we have tape drives that we drive to the bank every night. So databases.
But it's not handled from Kubernetes.
No, RDS. We defer that.
Or something like
What's that?
I see. But the Kubernetes containers talk to RDS.
Yep. So I should have given you an example config. We actually, like a config map, we actually pass a ton of environment variables to some of our servers, depending on what their needs are. And that's Redis caches and the partition to use and the database and other things for how to contact those assets. And that's all in Amazon. And so it's all in the Amazon network in US East 1. It's pretty fast, et cetera. So that's how we handle that. And yeah, there isn't really a lot of like block storage that we need. We use a lot of object storage, S3. But other than that, databases. So yeah, we defer that to AWS to manage. So go ahead, Josh.
What do you use for DNS names for load balancers and stuff? Do you have tools used to update them?
So there's a tool called external DNS.
That's what I was gonna say.
Yeah, that's all the rage. It is actually really cool. It interfaces with almost every major DNS provider. We use Cloudflare for most of our DNS handling for external names. We have some internal names defined in Route 53.
Why use Route for all of them?
What's that?
Why would you use Cloudflare?
So StockX.com is Cloudflare, right? And so it needs to be the authoritative DNS for that domain. StockX.io is Cloudflare, which is development and other staging, things like that. So that's in Cloudflare. So it just makes it a little bit easier. So one of those services, for instance, the staging version, external DNS would basically intercept I believe it's the ingress definition, and basically say, oh, this is the domain that you want. Cool, I'm going to make that happen. Go to Cloudflare, make sure service.staging.stockx.io exists, and then points to whatever we tell external DNS to point to. That could be the ELB, but if we have a model where we have an ingress controller like Nginx, then we might have an NLB pointing in front. That's a different ingress path that we have to tell external DNS about, so it configures that domain to actually go to the right place.
Out of curiosity, have you had issues with the sync versus upsert, the options of external DNS? Because I've seen, at least the Route 53 domain, it try and start changing other records because it's all in the same zone.
We haven't really looked at it that closely, and it hasn't really been running on our actual live clusters yet. React helped to get us there. I know it uses text records to keep kind of state. It doesn't have a tiller option. So I haven't looked. I don't think we've been bitten yet. I'll wait till there's a Saturday night P0 and we'll go from there. Super easy. Just a couple more questions. David.
Do you have any environments that you deploy to where the configuration can't be known ahead of time, and therefore you can't store as oh, this is my staging, this is my production? For example, being if I make an environment for PR or something, I make a new database, whether it's schema, instance, whatever, that PR, and now I have this config field, like your database connection URL.
Sure.
That's different just for that environment, so it's not going to be checked into my prop one. It's not going to be
So,
a secret that it reset up for prop.
Yeah. The short answer is no. The long answer is it's something we want to do. Talk to my team. That's something we've been thinking about as well. So.
Here's one.
But cool. Yeah. Good question. That's a good one. Go ahead in the back.
It looks like you did a lot of work to use.
I'm just going to take that statement right there. It looks like you did a lot of work. Thank you so much. Thank you for coming to the meetup. I love you. That's awesome. There's more pizza in the back. Sorry, continue.
Helm and parts and stuff. I'm wondering, do you think it's worth it? Would you do it again? Simpler to and the deployment animals to your dev team? Or you cuddle directly to say manage these deployments per service?
No.
You wouldn't do it again?
Oh, I'm sorry. I wouldn't.
I knew it. I knew you.
No to the second part. You tricked me. I would do what we did. You're saying have developers actually still applying configuration, right? Or
well, do they not apply it and they run Helm?
right now they don't run Helm. Well, so right now they're running kubectl to change a image.
So I guess all I'm saying is take Helm out of the picture. Would you have them manage templates that your CI, the circle would then talk to?
I wouldn't have them manage anything. DevOps would try to get a base template of what that should look like in a CI/CD process, and we would go from there, right? So if we were using Customize, which is another tool for generating configs, we would make that work in a pipeline and take the developer out of it as much as possible. We don't want them deploying. Actually, we like the gates are there kind of on, like, we don't want developers to have to deploy at all. We want that process to be standardized and agreed upon.
Right?
Yep. Right.
Right. Definition of CD, right?
Yep.
So that's beside the point. My real question is
That was just a troll.
Yeah. This guy,
My real
man.
question was the Helm part worth it? Or do you think?
Yes.
You're saying yes. Okay.
Yeah, I mean, if not Helm, maybe something else. Like, let's say there was a magical unicorn solution that's $4 billion valuation. Like, yes, we would pay for it too, gladly, because we're moving fast. And if a SaaS service makes our lives that much easier and it helps us meet those goals, we would do it. Would we get bit by it later? Probably DNS or certificates like StackPoint, like maybe, but then we'd reevaluate. And so our thing is, what gets us the return that we're looking for? What gets us 95% of the way that we can move with? It's not going to be perfect. We're going to kind of sigh whenever it comes up in conversation, but what gets us moving, right? And I would do Helm again. It's been a pain, but we've learned a lot. Developers have learned a lot, et cetera. So yeah. All right, one more question. Front.
How many users do you have, and how did you benchmark how many instances each service needed?
Don't know and don't know. How many users? So users, like external people going to StockX.com?
And users, yeah.
I don't really know the answer to that. 5 million? Eddie's telling me 5 million. So, which is blowing my mind right now.
You mentioned 10 as the instance count, so I was wondering if there was some kind of strategy of determining that.
No, we don't. You think we have strategies? That's no. Really, it depends on the service. What it's trying to do, how much data it's trying to process, what its core functionality is for the overall platform. It's really dependent on that. So a lot of it's scaling events that are reactive because of something happening. So we haven't dialed in based on we're actually working on that. We're actually working on resource usage as well to make sure, like, if the cluster has a totality of X resources, right? What is the stat, or what is the instance type, and what is the number of instances that should be running to optimize how we use that, right? Like that's a challenge in and of itself. So Charlie, who's sitting behind you, has been working on that front. So ask him questions. So my team is super anti-social. They're not super, but they're gonna get really mad at me right now. Please talk to them. I'm like kind of like, I know some stuff. They've really helped agree on my PRs and make me double check my things. All right, I am done. Thank you. Ask any questions that you have. George in the back, thank you to Miranda. Have a fantastic night. Thank you, guys.
All right.